Hey there and welcome to this video. We're going to take a look at how we can implement sequential search and also binary search in Java. And yeah, the approach or the algorithm should also be usable in other programming languages, but we talked about the theory, how the algorithms work in the previous video, and this is a small demo program of how the algorithms work in practice. And we can see that first off we got binary search here that is generic, so we got a T type specified here that will extend comparable as we talked in the previous video, and it is the iterative one. So we supply a list, and it's not an array this time, it's a list. That could be an array list, for instance, and then because it is a list, then we use other properties, other methods to actually get the size and also to get the values out, because if we use an array we just use the square brackets. Then we get sequential search, and again this is also converted to the list, also generic, so we're using size and we have equals that will check if the two values are equal. Okay. So if we take our small test program, we define the size of our input, how many numbers we want here, and then we basically iterate through a for loop and we add some strings with a number after it. Okay. Then we create a wanted string. We want to look for this string or whatever we want to look for, and then we have the collection sort, and when we're using a list we need to use collections. If we had an array we would use arrays. Sort instead. Okay, so we're using collections because we have a data structure in here more than just array. So we sort the array, and we need to do this because of binary search, because binary search works by sorting a sorted array, and if it is not sorted then it will not work. So so this is technically not necessary for the sequential search here. Okay, so if we provide the new string 99, then we get the result back here. It's going to return the index, and then we output it. So we can see we actually see if we can test the index to actually get the element out there. And I also test the native indexOf function method in the list interface to see, because this is basically the same way of searching, because you can use indexOf and then the object you want to search for as a sequential search. So we test if it will actually get the same index, and also if it can find the value. Then we test out binary search, and we have our homebrewed binary search here. We run the search, and then we also compare it to the collections, because there is actually a built-in implementation, a native JDK implementation in Java of binary search. So we test it against this one here, and we do the same output here. So let's see what happens if let's find the output again here. So we can see 99 and all the different implementations founded on this index. And the reason why the index might look a little strange is that it has been sorted. So they've been rearranged in order of their sorting. So if we change it to something else, if we want to look for 200 or something like that, the index is going to change. And just to see that binary search actually need to have a sorted array, if we remove this, comment this out, then we don't have a sorted array anymore. We're still looking for a new string 200. So if we test again, we will get an array index out of bounds exception, and this is because I'm trying to access the element at -1 here. And we can see that the place, you can see search test main, it's right here when we start our own homebrewed, or we actually output the result of the homebrewed binary search, and that is -1 here. So it indicates that it doesn't work because the other algorithms found it. Okay, so it needs to have a sorted collection to actually work. Alright, so this concludes the small series about how we can make sequential search and binary search and how they work. You can also do a lot of performance testing to search a whole bunch of collections to see how they would work and how many milliseconds they would take, or nanoseconds, but that's another video. Okay, so take care and hope you make this work. Bye bye.